Hello and welcome to Hive Tutorial. My name is Richard Kirshner with the Simplilearn team. That is www.simplilearn.com. Get certified, get ahead. What's in it for you today in our Hive tutorial? First, we're going to start with the history of Hive. What is Hive? Architecture of Hive, data flow in Hive, Hive data modeling, Hive data types, different modes of Hive, and difference between Hive and RDBMS. Finally, we're going to look into the features of Hive and do a quick hands-on demo on Hive in the Cloudera Hadoop file system. Let's dive in with a brief history of Hive. So the history of Hive begins with Facebook. Facebook began using Hadoop as a solution to handle the growing big data. And we're not talking about a data that fits on 1 or 2 or even 5 computers. We're talking data that fits on, if you've looked at any of our other Hadoop tutorials, you'll know we're talking about very big data and data pools. And Facebook certainly has a lot of data it tracks. As we know, the Hadoop uses MapReduce for processing data. MapReduce required users to write long codes. And so you'd have these really extensive Java codes, very complicated for the average person to use. Not all users were versed in Java and other coding languages. This proved to be a disadvantage for them. Users were comfortable with writing queries in SQL. SQL has been around for a long time, the standard SQL query language. Hive was developed with the vision to incorporate the concepts of tables, columns, just like SQL. So why Hive? Well, the problem was for processing and analyzing data, users found it difficult to code as not all of them were well versed with the coding languages. You have your processing, you have your analyzing, and so the solution was required a language similar to SQL, which was well known to all the users. And thus the Hive or HQL language evolved. What is Hive? Hive is a data warehouse system which is used for querying and analyzing large data sets stored in the HDFS or the Hadoop file system. Hive uses a query language that we call HiveQL or HQL, which is similar to SQL. So if we take our user, the user sends out their Hive queries, and then that is converted into a MapReduce tasks and then accesses the Hadoop MapReduce system. Let's take a look at the architecture of Hive. Architecture of Hive. We have the Hive client. So that could be the programmer, or maybe it's a manager who knows enough SQL to do a basic query to look up the data they need. The Hive client supports different types of client applications in different languages for performing queries. And so we have our Thrift application and the Hive Thrift client. Thrift is a software framework. Hive server is based on Thrift, so it can serve the requests from all programming languages that support Thrift. And then we have our JDBC application and the Hive JDBC driver. JDBC, Java Database Connectivity. JDBC application is connected through the JDBC driver. And then you have the ODBC application, or the Hive ODBC driver. The ODBC, or Open Database Connectivity, the ODBC application is connected through the ODBC driver. With the growing development of all of our different scripting languages, Python, C++, Spark, Java, you can find just about any connection in any of the main scripting languages. And so we have our Hive services. As we look deeper into the architecture, Hive supports various services. So you have your Hive server, basically your Thrift application or your Hive Thrift client or your JDBC or your Hive JDBC driver, your ODBC application or your Hive ODBC driver. They all connect into the Hive server. And you have your Hive web interface. You also have your CLI. Now, the Hive web interface is a GUI is provided to execute Hive queries. And we'll actually be using that later on today, so you can see kind of what that looks like and get a feel for what that means. Commands are executed directly in CLI. And then the CLI is a direct terminal window. And I'll also show you that too, so you can see how those two different interfaces work. These then push the code into the Hive driver. Hive driver is responsible for all the queries submitted, so everything goes through that driver. Let's take a closer look at the Hive driver. The Hive driver now performs 3 steps internally. One is a compiler. Hive driver passes query to compiler where it is checked and analyzed. Then the optimizer kicks in, and the optimized logical plan in the form of a graph of MapReduce and HDFS tasks is obtained. And then finally, in the executor, in the final step, the tasks are executed. When we look at the architecture, we also have to note the metastore. Metastore is a repository for Hive metadata. It stores metadata for Hive tables. And you can think of this as your schema and where is it located. And it's stored on the Apache DB. Processing and resource management is all handled by the MapReduce v1. You'll see MapReduce v2, the Yarn, and the Tez. These are all different ways of managing these resources depending on what version of Hadoop you're in. Hive uses MapReduce framework to process queries. And then we have our distributed storage, which is the HDFS. And if you looked at our Hadoop tutorials, you'll know that these are on commodity machines and are linearly scalable. That means they're very affordable. A lot of time when you're talking about big data, you're talking about 1/10 of the price of storing it on enterprise computers. And then we look at the data flow in Hive. So in our data flow in Hive, we have our Hive in the Hadoop system. And underneath the user interface, or the UI, we have our driver, our compiler, our execution engine, and our metastore. That all goes into the MapReduce and the Hadoop file system. So when we execute a query, you can see it coming in here, it goes into the driver, step 1. Step 2, we get a plan. What are we going to do? Refers to the query execution. Then we go to the metadata. And it's like, well, what kind of metadata are we actually looking at? Where is this data located? What is the schema on it? Then it comes back with the metadata into the compiler. Then the compiler takes all that information and the send plan returns it to the driver. The driver then sends the execute plan to the execution engine. Once it's in the execution engine acts as a bridge between Hive and Hadoop to process the query. And that's going into your MapReduce and your Hadoop file system, or your HDFS. And then we come back with the metadata operations. It goes back into the metastore to update or let it know what's going on, which also goes to it's a communication between the execution engine and the metastore. Execution engine communications is bidirectionally with the metastore to perform operations like create, drop tables. Metastore stores information about tables and columns. So again, we're talking about the schema of your database. And once we have that, we have a bi-directional send results communication back into the driver. And then we have the fetch results, which goes back to the client. So let's take a look at the Hive data modeling. Hive data modeling. So you have your Hive data modeling, you have your tables, you have your partitions, and you have buckets. The tables in Hive are created the same way it is done in RDBMS. So when you're looking at your traditional SQL Server or MySQL Server, where you might have enterprise equipment and a lot of people pulling and moving stuff off of there, the tables are going to look very similar. And this makes it very easy to take that information, and let's say you need to keep current information, but you need to store all of your years of transactions back into the Hadoop Hive. So you match those. Those all kind of look the same. The tables are the same. Your databases look very similar, and you can easily import them back. You can easily store them into the Hive system. Partitions. Here, tables are organized into partitions for grouping same type of data based on partition key. This can become very important for speeding up the process of doing queries. So if you're looking at dates, as far as like your employment dates of employees, if that's what you're tracking, you might add a partition there because that might be one of the key things that you're always looking up as far as employees are concerned. And finally, we have buckets. Data present in partitions can be further divided into buckets for efficient querying. Again, there's that efficiency. At this level, a lot of times you're working with the programmer and the admin of your Hadoop file system to maximize the efficiency of that file system. So it's usually a two-person job when we're talking about Hive data modeling. You want to make sure that they work together and you're maximizing your resources. Hive data types. So we're talking about Hive data types. We have our primitive data types and our complex data types. A lot of this will look familiar because it mirrors a lot of stuff in SQL. In our primitive data types, we have the numerical data types, string data type, date time data type, and miscellaneous data type. And these should be they're kind of self-explanatory, but just in case. Numerical data is your floats, your integers, your short integers. All of that numerical data comes in as a number. A string, of course, is characters and numbers. And then you have your date timestamp, and then we have kind of a general way of pulling your own created data types in there. That's our miscellaneous data type. And we have complex data types. So you can store arrays, you can store maps, you can store structures, and even units in there. As we dig into Hive data types, and we have the primitive data types and the complex data types. So we look at primitive data types, and we're looking at numeric data types. Data types like an integer, a float, a decimal, those are all stored as numbers in the Hive data system. A string data types like characters and strings. You store the name of the person you're working with, John Doe, the city, Memphis, the state, Tennessee. Maybe it's Boulder, Colorado, USA, or maybe it's Hyderabad, India. That's all going to be string and stored as a string character. And of course we have our date time data type. Data types like timestamp, date, interval. Those are very common as far as tracking cells, anything like that. So you can just think if you can type a stamp of time on it, or maybe you're dealing with a race and you want to know the interval, how long did the person take to complete whatever task it was. All of that is date time data type. And then we talk miscellaneous data type. These are like Boolean and binary. And when you get into Boolean and binary, you can actually almost create anything in there. But your yes, no's, 0, 1. Now let's take a look at complex data types a little closer. We have arrays. So your syntax is of data type, and it's an array. And you can just think of an array as a collection of same entities, 1, 2, 3, 4, if they're all numbers. And you have maps. This is a collection of key value pairs. So understanding maps is so central to Hadoop. So when we store maps, you have a key, which is a set. You can only have one key per mapped value. And so you, in Hadoop, of course, you collect the same keys and you can add them all up or do something with all the contents of the same key. But this is our map as a primitive type data type in our collection of key value pairs. And then collection of complex data with comment. So we can have a structure where you have like column name, data type, comment, column comment. So you can get very complicated structures in here with your collection of data and your commented setup. And then we have units, and this is a collection of heterogeneous data types. So the syntax for this is union type, data type, and so on. So it's all going to be the same. A little bit different than the arrays where you can actually mix and match. Different modes of Hive. Hive operates in two modes depending on the number and size of data nodes. We have our local mode and our map reduce mode. When we talk about the local mode, it is used when Hadoop is having one data node and the data is small. Processing will be very fast on a smaller data sets, which are present in local machine. And this might be that you have a local file of stuff you're uploading into the Hive, and you need to do some processes in there. You can go ahead and run those Hive processes and queries on it. Usually, you don't see much in the way of a single node Hadoop system. If you're going to do that, you might as well just use like an SQL database or even a Java SQLite or something. Python is SQLite. So you don't really see a lot of single node Hadoop databases, but you do see the local mode in Hive where you're working with a small amount of data that's going to be integrated into the larger database. And then we have the map reduce mode. This is used when Hadoop is having multiple data nodes and the data is spread across various data nodes. Processing large data sets can be more efficient using this mode. And this you can think of, instead of it being 1, 2, 3, or even 5 computers, we're usually talking with the Hadoop file system, we're looking at 10 computers, 15, 100, where this data is spread across all those different Hadoop nodes. Difference between Hive and RDBMS. Remember, RDBMS stands for the Relational Database Management System. Let's take a look at the difference between Hive and the RDBMS. With Hive, Hive enforces schema on read. And it's very important that whatever's coming in, that's when Hive's looking at it and making sure that it fits the model. The RDBMS enforces a schema when it actually writes the data into the database. So it's read the data, and then once it starts to write it, that's where it's going to give you the error or tell you something's incorrect about your scheme. Hive data size is in petabytes. That is hard to imagine. When we're looking at your personal computer on your desk, maybe you have 10 terabytes if it's a high-end computer. But we're talking petabytes, so that's hundreds of computers grouped together. When RDBMS, data size is in terabytes. Very rarely do you see an RDBMS system that's spread over more than 5 computers. And there's a lot of reasons for that. With the RDBMS, it actually has a high-end amount of writes to the hard drive. There's a lot more going on there. You're writing and polling stuff. So you really don't want to get too big with an RDBMS or you're going to run into a lot of problems. With Hive, you can take it as big as you want. Hive is based on the notion of write once and read many times. This is so important. They call it worm, which is write, W, once, O, read, R, many times, M. They refer to it as worm, and that's true of a lot of your Hadoop setup. It's altered a little bit, but in general, we're looking at archiving data that you want to do data analysis on. We're looking at pulling all that stuff off your RDBMS from years and years and years of business, or whatever your company does, or scientific research, and putting that into a huge data pool so that you can now do queries on it and get that information out of it. With the RDBMS, it's based on the notion of read and write many times. So you're continually updating this database. You're continually bringing up new stuff, new cells. The count changes because they have a different licensing now, whatever software you're selling, all that kind of stuff where the data is continually fluctuating. And then Hive resembles a traditional database by supporting SQL, but it is not a database. It is a data warehouse. This is very important, and it goes with all the other stuff we've talked about, that we're not looking at a database but a data warehouse to store the data and still have fast and easy access to it for doing queries. You can think of Twitter and Facebook. They have so many posts that are archived back historically. Those posts aren't going to change. They made the post, they're posted, they're there, and they're in their database, but they have to store it in a warehouse in case they want to pull it back up. With the RDBMS, it's a type of database management system which is based on the relational model of data. And then with Hive, easily scalable at a low cost. Again, we're talking maybe $1,000 per terabyte. The RDBMS is not scalable at a low cost. When you first start on the lower end, you're talking about $10,000 per terabyte of data, including all the backup on the models and all the added necessities to support it. As you scale it up, you have to scale those computers and hardware up. So you might start off with a basic server, and then you upgrade to a Sun computer to run it, and you spend tens of thousands of dollars for that hardware upgrade. With Hive, you just put another computer into your Hadoop file system. So let's look at some of the features of Hive. When we're looking at the features of Hive, we're talking about the use of SQL-like language called HiveQL. A lot of times you'll see that as HQL, which is easier than long codes. This is nice if you're working with your shareholders. You come to them and you say, hey, you can do a basic SQL query on here and pull up the information you need. This way, you don't have to have your programmers jump in every time they want to look up something in the database. They actually now can easily do that if they're not skilled in programming and script writing. Tables are used which are similar to the RDBMS, hence easier to understand. And one of the things I like about this is when I'm bringing tables in from a MySQL server or SQL server, there's almost a direct reflection between the two. So when you're looking at one, which is a data which is continually changing, and then you're going into the archive database, it's not this huge jump where you have to learn a whole new language. You mirror that same schema into the HDFS, into the Hive, making it very easy to go between the two. And then using HiveQL, multiple users can simultaneously query data. So again, you can have multiple clients in there and they send in their query. That's also true with the RDBMS, which kind of queues them up. Because it's running so fast, you don't notice the lag time. Well, you get that also with the HQL. As you add more computers in, the query can go very quickly, depending on how many computers and how much resources each machine has to pull the information. And Hive supports a variety of data types. So with Hive, it's designed to be on the Hadoop system, which you can put almost anything into the Hadoop file system. So with all that, let's take a look at a demo on HiveQL or HQL. Before I dive into the hands-on demo, let's take a look at the website, hive.apache.org. That's the main website since Apache, it's an Apache open source software. This is the main software or the main site for the build. And if you go in here, you'll see that they're slowly migrating Hive into Beehive. And so if you see Beehive versus Hive, note the Beehive is the new release is coming out. That's all it is, and it reflects a lot of the same functionality of Hive. It's the same thing. And then we like to pull up some kind of documentation on commands. And for this, I'm actually going to go to Hortonworks Hive cheat sheet. And that's because Hortonworks and Cloudera are two of the most common used builds for Hadoop and for which include Hive and all the different tools in there. And so Hortonworks has a pretty good PDF you can download cheat sheet on there. I believe Cloudera does too, but we'll go ahead and just look at the Horton one, because it's the one that comes up really good. And you can see when we look at the query language, it compares MySQL Server to HiveQL or HQL. And you can see the basic select. We select from columns, from table where conditions exist. Most basic command on there. And they have different things you can do with it, just like you do with your SQL. And if you scroll down, you'll see data types. So here's your integer, your float, your binary, double string, timestamp, and all the different data types you can use. Some different semantics. has different keys, features, functions for running a Hive query, command line setup, and of course the Hive shell setup in here. So you can see right here, if we loop through it, it has a lot of your basic stuff. And we're basically looking at SQL across a Horton database. We're going to go ahead and run our Hadoop cluster Hive demo. And I'm going to go ahead and use the Cloudera Quick Start. And this is in the virtual box. So again, we have an Oracle virtual box, which is open source. And then we have our Cloudera Quick Start, which is the Hadoop setup on a single node. Now, obviously, Hadoop and Hive are designed to run across a cluster of computers. So when we talk about a single node, is for education, testing, that kind of thing. And if you have a chance, you can always go back and look at our demo we had on setting up a Hadoop system in a single cluster. Just set a note down below in the YouTube video, and our team will get in contact with you and send you that link if you don't already have it. Or you can contact us at the www.simplilearn.com. Now in here, it's always important to note that you do need on your computer, if you're running on Windows, because I'm on a Windows machine, you're going to need probably about 12 gigabytes to actually run this. It used to be you could get by with a lot less, but as things have evolved, they take up more and more resources. And you need the professional version. If you have the home version, I was able to get that to run, but boy, did it take a lot of extra work to get the home version to let me use the virtual setup on there. And we'll simply click on the Cloudera Quick Start, and I'm going to go and just start that up. And this is starting up our Linux. So we have our Windows 10, which is the computer I'm on, and then I have the virtual box, which is going to have a Linux operating system in it. And we'll skip ahead so you don't have to watch the whole install. Something interesting to know about the Cloudera is that it's running on Linux CentOS, and for whatever reason, I've always had to click on it and hit the escape button for it to spin up. And then you'll see the DOS come in here. Now that our Cloudera is spun up on our virtual machine with the Linux on, we can see here we have our, it uses the Thunderbird browser on here by default and automatically opens up a number of different tabs for us. And a quick note, because I mentioned like the restrictions on getting set up on your own computer. If you have a home edition computer and you're worried about setting it up on there, you can also go in there and spin up a 1-month free service on Amazon Web Service to play with this. So there's other options. You're not stuck with just doing it on the quick start menu. You can spin this up in many other ways. Now the first thing we want to note is that we've come in here into Cloudera, and I'm going to access this in 2 ways. The first one is we're going to use Hue. And I'm going to open up Hue, and it'll take it a moment to load from the setup on here. And Hue is nice. If I go in and use Hue as an editor into Hive or into the Hadoop setup, usually I'm doing it as a from an admin side, because it has a lot more information, a lot of visuals, less to do with actually diving in there and just executing code. And you can also write this code into files and scripts, and there's other ways you can upload it into Hive. But today we're going to look at the command lines, and we'll upload it into Hue, and then we'll go into and actually do our work in a terminal window under the Hive shell. Now in the Hue browser window, if you go under Query and click on the pull down menu, and then you go under Editor, and you'll see Hive. There we go. There's our Hive setup. I go and click on Hive, and this will open up our query down here, and now it has a nice little B that shows our Hive going, and we can go something very simple down here like show databases, and we follow it with the semicolon. And that's the standard in Hive, is you always add our punctuation at the end there. And I'll go ahead and run this, and the query will show up underneath. And you'll see down here, since this is a new quick start I just put on here, you'll see it has the default down here for the databases. That's the database name. I haven't actually created any databases on here. And then there's a lot of other like assistant function, tables, your databases up here. There's all kinds of things you can research, you can look at through Hue as far as a bigger picture. The downside of this is it always seems to lag. For me, whenever I'm doing this, I always seem to run slow. So if you're in Cloudera, you can open up a terminal window. They actually have an icon at the top. You can also go under Applications, and under Applications, System Tools, and Terminal. Either one will work. It's just a regular terminal window. And this terminal window is now running underneath our Linux. So this is a Linux terminal window, or on our virtual machine, which is resting on our regular Windows 10 machine. And we'll go ahead and zoom this in so you can see the text better on your own video. And I simply we just clicked on View and Zoom in, and then all we have to do is type in Hive, and this will open up the shell on here, and it takes it just a moment to load. When starting up Hive, I also want to note that depending on your rights on the computer you're on in your action, you might have to do sudo Hive and put in your password and username. Most computers are usually set up with the Hive login. Again, it just depends on how you're accessing the Linux system and the Hive shell. Once we're in here, we can go ahead and do a simple HQL command, show databases, and if we do that, we'll see here that we don't have any databases. So we can go ahead and create a database, and we'll just call it Office for today, for this moment. Now if I do show, we'll just do the up arrow. Up arrow is a hotkey that works in both Linux and in Hive, so I can go back and paste through all the commands I've typed in. And we can see now that I have my, there's of course the default database, and then there's the Office database. So now we've created a database. It's pretty quick and easy. And we can go ahead and drop the database. We can do drop database Office. Now this will work on this database because it's empty. If your database was not empty, you would have to do cascade, and that drops all the tables in the database and the database itself. Now if we do show database, and we'll go ahead and recreate our database because we're going to use the Office database for the rest of this hands-on demo. A really handy command to now set with the SQL or HQL is to use Office. And what that does is that sets Office as the default database. So instead of having to reference the database every time we work with a table, it now automatically assumes that's the database being used for whatever tables we're working on. The difference is you put the database name period table, and I'll show you in just a minute what that looks like and how that's different. If we're going to have a table and a database, we should probably load some data into it. So let me go ahead and switch gears here and open up a terminal window. You can just open another terminal window and it'll open up right on top of the one that you have Hive shell running in. And when we're in this terminal window, first we're going to go ahead and just do a list, which is of course a Linux command. You can see all the files I have in here. This is the default load. We can change directory to documents. We can list in documents, and we're actually going to be looking at employee.csv. A Linux command is the cat. You can use this actually to combine documents. There's all kinds of things that cat does, but if we want to just display the contents of our employee.csv file, we can simply do cat employee CSV. And when we're looking at this, we want to know a couple things. One, there's a line at the top. Okay, so the very first thing we notice is that we have a header line. The next thing we notice is that the data is comma separated, and in this particular case you'll see a space here. Generally with these you got to be real careful with spaces. There's all kinds of things you got to watch out for because they can cause issues. These spaces won't, because these are all strings that the space is connected to. If this was a space next to the integer, you would get a null value that comes into the database without doing something extra in there. Now with most of Hadoop, that's important to know that you're writing the data once, reading it many times, and that's true of almost all your Hadoop things coming in. So you really want to process the data before it gets into the database. And for those of you who have studied data transformation, that's the ETL, where you extract, transfer, form, and then load the data. So you really want to extract and transform before putting it into the Hive. Then you load it into the Hive with the transformed data. And of course we also want to note the schema. We have an integer, string, string, integer, integer. So we kept it pretty simple in here as far as the way the data is set up. The last thing that you're going to want to look up is the source. Since we're doing local uploads, we want to know what the path is. We have the whole path. In this case it's home/cloudera/documents. And these are just text documents we're working with right now. We're not doing anything fancy. So we can do a simple get edit employee.csv, and you'll see it comes up here. It's just a text document, so I can easily remove these added spaces. There we go. And then we go ahead and just save it. And so now it has the new setup in there. We've edited it. The gedit is usually one of the default that loads into Linux. So any text editor will do. Back to the Hive shell. So let's go ahead and create a table employee. And what I want you to note here is I did not put the semicolon on the end here. A semicolon tells it to execute that line. So this is kind of nice if you can actually just paste it in if you have it written on another sheet. And you can see right here where I have create table employee, and it goes into the next line on there so I can do all of my commands at once. Now, just so I don't have any typo errors, I went ahead and just pasted the next 3 lines in. And the next one is our schema. If you remember correctly from the other side, we had the different values in here, which was ID, name, department, year of joining, and salary. And the ID is an integer, name is a string, department string, year of joining integer, salary an integer. And they're in brackets. We put closed brackets around them. And you could do this all as one line. And then we have row format delimited fields terminated by comma. And this is important because the default is tabs. So if I do it now, it won't find any terminated fields. So you'll get a bunch of null values loaded into your table. And then finally, our table properties, we want to skip the header line count equals 1. Now, this is a lot of work for uploading a single file. It's kind of goofy when you're uploading a single file that you have to put all this in here. But keep in mind, Hive in Hadoop is designed for writing many files into the database. You write them all in there and then they're saved. It's an archive. It's a data warehouse. And then you're able to do all your queries on them. So a lot of times we're not looking at just the one file coming up. We're loading hundreds of files. You have your reports coming off of your main database. All those reports are being loaded. You have your log files, you have, all this different data is being dumped into Hadoop, and in this case Hive on top of Hadoop. And so we need to let it know, hey, how do I handle these files coming in? And then we have the semicolon at the end, which lets us know to go ahead and run this line. And so we'll go ahead and run that. And now if we do a show tables, you can see there's our employee on there. We can also describe. If we do describe employee, you can see that we have our ID integer, name string, department string, year of joining integer, and salary integer. And then finally, let's just do a select star from employee, very basic SQL and HQL command, selecting data. And it's going to come up and we haven't put anything in it, so as we expect, there's no data in it. So if we flip back to our Linux terminal window, you can see where we did the cat employee.csv, and you can see all the data we expect to come into it. And we also did our pwd, and right here you see the path. You need that full path when you are loading data. You can do a browse, and if I did it right now with just the employee.csv as a name, it will work. But that is a really bad habit. In general, when you're loading data, because it's you don't know what else is going on the computer, you want to do the full path almost in all your data loads. So let's go ahead and flip back over here to our Hive shell we're working in. And the command for this is load data. So that says, hey, we're loading data. That's a Hive command, HQL. And we want local data, so you got to put down local in path. So now it needs to know where the path is. Now, to make this more legible, I'm just going to go ahead and hit enter, and then we'll just paste the full path in there, which I have stored over on the side, like a good prepared demo. And you'll see here we have home, Cloudera, documents, employee.csv. So it's a whole path for this text document in here. And we go ahead and hit enter in there, and then we have to let it know where the data is going. So now we have a source and we need a destination. And it's going to go into the table, and we'll just call it employee. We'll just match the table in there. And because I want it to execute, we put the semicolon on the end. It goes ahead and executes all 3 lines. Now if we go back, if you remember we did the select star from employee, just using the up arrow to page through my different commands I've already typed in. You can see right here we have, as we expect, we have Rose, Sam, Mike, and Nick, and we have all their information showing in our 4 rows. And then let's go ahead and do select and count. We'll just look at a couple of these different select options you can do. We're going to count everything from employee. Now this is kind of interesting because the first one just pops up with the basic select, because it doesn't need to go through the full map reduce phase. But when you start doing a count, it does go through the full map reduce setup in the Hive and Hadoop. And because I'm doing this demo on a single node Cloudera virtual box on top of a Windows 10, all the benefits of running it on a cluster are gone, and instead it's now going through all those added layers, so it takes longer to run. Like I said, when you do a single node, as I said earlier, it doesn't do any good as an actual distribution because you're only running it on one computer, and then you've added all these different layers to run it. And we see it comes up with 4, and that's what we expect. We have 4 rows. We expect 4 at the end. And if you remember from our cheat sheet, which we brought up here from Horton's, it's a pretty good one. There's all these different commands we can do. We'll look at one more command where we do the what they call subqueries right down here, because that's really common to do a lot of subqueries. And so we'll do select star, or all different columns from employee. Now if we weren't using the Office database, it would look like this, from office.employee. employee. And either one will work on this particular one because we have office set as a default on there. So from office employee, and then the command where creates a subset. And in this case, we want to know where the salary is greater than 25,000. There we go. And of course we end with our semicolon. And if we run this query, you can see it pops up, and there's our salaries of people, top earners. We have Rose in IT and Mike in HR. Kudos to them. Of course, they're fictional. We don't actually have a Rose and a Mike in those positions, or maybe we do. So finally, what we want to go ahead and do is we're done with this table. Now remember, you're dealing with a data warehouse, so you usually don't do a lot of dropping of tables and databases. But we're going to go ahead and drop this table here. Before we drop it, one more quick note is we can change it. So what we're going to do is we're going to alter table, office, employee, and we want to go ahead and rename it. There's some other commands you can do in here, but rename is pretty common. And we're going to rename it to, and it's going to stay in office, and it turns out one of our shareholders really doesn't like the word employee. He wants employees plural. It's a big deal to him. So let's go ahead and change that name for the table. It's that easy because it's just changing the metadata on there. And now if we do show tables, you'll see we now have employees, not employee. And then at this point, maybe we're doing some house cleaning because this is all practice. So we're going to go ahead and drop table, and we'll drop table employees because we changed the name in there. So if we did employee, just give us an error. And now if we do show tables, you'll see all the tables are gone. Now the next thing we want to go ahead and take a look at, and we're going to walk back through the loading of data just real quick because we're going to load 2 tables in here. And let me just float back to our terminal window so we can see what those tables are that we're loading. And so up here we have a customer file, and we have an order file. We want to go ahead and put the customers and the orders into here. So those are the 2 we're doing. And of course, it's always nice to see what you're working with. So let's do our cat customer.csv. We could always do gedit, but we don't really need to edit these. We just want to take a look at the data in customer. And important in here is, again, we have a header, so we have to skip a line, comma separated. Nothing odd with the data. We have our schema, which is integer, string, integer, string, integer. So you'd want to take that, note that down, or flip back and forth when you're doing it. And then let's go ahead and do cat order.csv, and we can see we have OID, which I'm guessing is the order ID. We have a date. Oh, something new. We've done integers and strings, but we haven't done date. When you're importing new and you never worked with the date, date's always one of the more trickier fields to port in. And that's true of just about any scripting language I've worked with. All of them have their own idea of how date's supposed to be formatted, what the default is. This particular format, where it's year, and it has all 4 digits, dash month, 2 digits, dash day, is the standard import for the Hive. So you'll have to look up and see what the different formats are if you're going to do a different format in there coming in, or you're not able to pre-process the data. But this would be a pre-processing of the data thing coming in. If you remember correctly from our ETL, which is just in case you weren't able to hear me last time, ETL, which stands for extract, transform, then load. So you want to make sure you're transforming this data before it gets into here. And so we're going to go ahead and bring both this data in here. And really we're doing this so we can show you the basic join. There is, if you remember from our setup, merge, join, all kinds of different things you can do. But joining different data sets is so common. So it's really important to know how to do this. We need to go ahead and bring in these 2 data sets. And you can see where I just created a table customer. Here's our schema, the integer, name, age, address, salary. Here's our delimited by commas, and our table properties where we skip a line. Well, let's go ahead and load the data first, and then we'll do that with our order. And let's go ahead and put that in here, and I've got it split into 3 lines so you can see it easily. We got load data local in path. So we know we're loading data, we know it's local, and we have the path. Here's the complete path for, oops, this is supposed to be order, CSV. Grab the wrong one. Of course, it's going to give me errors because you can't recreate the same table on there. And here we go, create table. Here's our integer, date, customer, the basic setup that we had coming in here for our schema, row format, commas, table properties, skip header line. And then finally, let's load the data into our order table. Load data local in path, home Cloudera documents order.csv into table order. Now, if we did everything right, we should be able to do select star from customer. And you can see we have all 7 customers, and then we can do select star from order, and we have 4 orders. So this is just like a quick frame. We have, a lot of times when you have your customer databases in business, you have thousands of customers from years and years, and some of them, they close their business, they change names, all kinds of things happen. So what we want to do is we want to go ahead and find just the information connected to these orders and who's connected to them. And so let's go ahead and do, it's a select, because we're going to display information. So select, and this is kind of interesting. We're going to do c.id, and I'm going to define C as customer, as a customer table in just a minute. Then we're going to do c.name, and again we're going to define the c.age. So this means from the customer we want to know their ID, their name, their age, and then I'd also like to know the order amount. So let's do O for .amount. And then this is where we need to go ahead and define what we're doing. And I'll go ahead and capitalize from customer. So we're going to take the customer table in here, and we're going to name it C. That's where the C comes from. So that's the customer table C, and we want to join order as O. That's where our O comes from. So the O.amount is what we're joining in there. And then we want to do this on, we got to tell it how to connect the 2 tables. C.id equals O.customer underscore ID. So now we know how they're joined. And now remember, we have 7 customers in here. We have 4 orders. And as it processes, we should get a return of 4 different names joined together. And they're joined based on, of course, the orders on there. And once we're done, we now have the order number, the person who made the order, their age, and the amount of the order, which came from the order table. So you have your different information, and you can see how the join works here. Very common use of tables and HQL and SQL. And let's do one more thing with our database, and then I'll show you a couple other Hive commands. And let's go ahead and do a drop, and we're going to drop database office. And if you're looking at this and you remember from earlier, this will give me an error. And let's just see what that looks like. It says failed to execute, exception, 1 or more tables exist. So if you remember from before, you can't just drop a database unless you tell it to cascade. That lets it know, I don't care how many tables are in it, let's get rid of it. And in Hadoop, since it's a warehouse, a data warehouse, you usually don't do a lot of dropping. Maybe at the beginning when you're developing the schemas and you realize you messed up, you might drop some stuff. But down the road, you're really just adding commodity machines to take up so you can store more stuff on it. So you usually don't do a lot of database dropping. And some other fun commands to know is you can do select round 2.3 as round value. You can do a round off in Hive. We can do as floor value, which is going to give us a 2, so it turns it into an integer versus a float. It goes down, basically truncates it, but it goes down. And we can also do ceiling, which is going to round it up. So we're looking for the next integer above. There's a few commands we didn't show in here because we're on a single node. As an admin, to help expedite the process, you usually add in partitions for the data and buckets. You can't do that on a single node because when you add a partition, it partitions it across separate nodes. But beyond that, you can see that it's very straightforward. We have SQL coming in, and all your basic queries that are in SQL are very similar to HQL. Key takeaways. So we took a look at the history of Hive and how it evolved from the Hadoop file system to an HQL, similar to SQL, layer on top of Hadoop with the full metastore and all that information connected to the Hadoop file system. That way you can easily scale it up and still have, underneath the Hadoop setup while still having the SQL query language available. We looked at what is Hive. And we looked at the Hive queries going in through the MapReduce into the Hadoop MapReduce system. We dug a little deeper to look at the architecture of Hive and all the different pieces and how they fit together, including the fact that it has the Hive client and you have your Thrift applications and your JDBC applications and your ODBC applications. We have the Hive web interface, which we looked at in a demo, along with the CLI, which is your client direct interface, which we use for most of the demo. And again, this is how do you get these commands into Hive. And if you're using the Hive web interface, is great. for maybe your shareholders you're working with, and some of them are not technically literate, or even if they are, it's a quick lookup for data. I'm not beyond jumping into the Hue web interface and looking something up versus a terminal window. Or if you're running in the back end, we're running the program, whether it's Python or Java, you have those the Thrift applications which connect in. So you connect in with all the major scripting languages, usually have their own plugin for sending that information over to our Hadoop file system. We dug in deeper into the data flow in Hive. So your user interface and the different steps it takes to go through and get in and out of the MapReduce system. We also took a glance at Hive data types, and certainly these are always evolving, so it's good to look at the Apache website, and especially with the new stuff come up underneath of Beehive, which is also Hive. If you see that, don't let that scare you. It's just the beta version coming up with the new updates. And then we looked at the features of Hive and how it works as an ecosystem on there. With that, I'd like to thank you for joining us today for Hadoop Hive. Again, my name is Richard Kirschner with the Simplilearn team. For more information, visit us at www.simplilearn.com. You can also post comments here on the YouTube channel. We do have moderators that monitor that, and we certainly will respond to your postings. Again, thank you for joining us today. Get certified, get ahead.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.